By the end of this section, we should be able to find the domain and range of exponential functions, find the inverse of exponential functions, graph logarithmic functions, find the domain and range of logarithmic functions, find inverses of logarithmic functions, and that's about it. So way back in 7.1, we graphed exponential functions, and then we moved through the chapter. We learned that exponential functions have inverses called logarithms. So remember, inverses undo each other just like multiplication and division. Today, we're going to go back and we're going to discuss how to graph those logarithmic functions based on our graphs on the idea that the logarithmic and the exponential functions are inverses. So problem 1 just says, remember how to graph exponential functions. Please graph the following function. Give the domain and the range of the functions. We've got y is equal to 2 to the x minus 3 minus 4. Alright, so thinking about this, I should have an asymptote at -4 sitting there on the end. I don't see a negative exponent that would flip this, so this should be a growth, so it should be going up and up and up, something like that. Alright, so I just need to plug stuff in to my parent function. So my parent function is just y is equal to 2 to the x. T-charting this, I should get x and y. I'm going to plug in -1, get 1/2. I'm going to plug in 0. I'm going to get 1. I plug in 1, I'm going to get 2. I plug in 2, I'm going to get 4. I plug in 3, I'm going to get 8. And I plug in 4, and then I'm going to get 16. That's my t-chart. And then from here, the only things that I see other than my parent function are this -3, which is going to shift me right 3. And then this -4, which is going to shift me down 4. So really, I just need to shift my x coordinates right 3, which will just add 3 to my x coordinates, and then shifting my entire graph down 4 should shift all of my y coordinates down 4, therefore subtracting 4 from those y coordinates. Alright, so if you'd like, you can go ahead and graph that parent function and then do that. So -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8, and then 4, 16 doesn't quite fit, but shifting those right 3 and down 4. Right 3, down 4. 1, 2, 3, 2, 3. And then finally, we should see that shifting 16 down 4 should put me at, what, 12? And I think my graph is a 12 by 12 if I remember right. So that point might actually fit on my graph now. It is. Alright, and I'm going to make that asymptote red just like the rest of my function here. Just to kind of highlight that's where my new function is. Alright, other than that, my original asymptote should have been at y equals 0, which you guys can't really see because I made that line really, really thick. Alright, other than that, we just have to connect our new dots. And we call it a day. Alright, so looking at this function, I see that there's not an x that I can't plug in. It's going to give me either a really, really small fraction, or it's going to give me a very, very large number as far as my y goes. So there's no x that I can't plug in and get a y. So my domain in this case is going to be all real numbers, aka -infinity to +infinity. Alright, but my range though, my y values, well, they don't start until this asymptote, which is at 4. And then it goes up and up and up forever towards infinity. Alright, and that 4 is not included because, well, it's an asymptote. We can't actually touch that. Alright, and that's about all there is to those. And set builder notation, for those of you who like set builder, is a set of all x's such that x is greater than, oops, that's not an x. X is greater than -4. So again, that's read the set of all x's such that x is greater than -4. Then you just close the set and you're done. And the set builder on domain was the set of all real numbers sitting right here. That's that weird R thing. So you can use interval or set builder. Personally, I prefer interval, but some of you guys like set builder.